Hello, mentors. Welcome to Meeting 7, Trust, on November 16th. And so this will have two activities, and both are games. The Barrio game, it's a cooperative game, and the idea is to use math to learn about how trust works. And then the Climate game, which pretty much is the same goals, it's a similar game, and we have this text. What happens when little things about cooperating in games change? Let's find out. So the general theme is you have a game, you have some trust going on. How do the rules of the game can affect how people play in terms of the trust? Also, how many players do play and what effect does it have? So all these variation, it's gonna be a meeting, a very interesting meeting because students will get to know just not just one game, but two games, but actually with variations. And then it's about reflecting mathematically and also culturally what are these things, what are the effects of these things on the games and on the other players, on the perspectives. So let's take a look at the overview. In the Barrio game, students will play a game in which they can play just to benefit themselves, being kind of selfish, or to help everyone as a team. Mentors will help students reflect about the mathematics behind them and the implications in real life context. So we'll practice 2.3, ask thinking questions. And let me just show you the manual. We have, of course, as you've done this per deck throughout the meetings, we always have these analyzing, generalizing, and justifying questions. And this meeting, it's all about asking these type of questions. So we've practiced all meetings these questions. So in the per deck, you have chances to practice as well. The second part, the climate game, students will play a similar game, but with important rule changes. They will analyze this game, compare it with the previous one, and come up with other variations. Just to talk about time management, there's two key tips for this meeting. The first one is practice, practice, practice. Practice playing all the games, all the variations before you can come up with new ones, and also rehearse how you will explain the rules efficiently. In my experience playing games with my friends and with other pals, the best is to play, of course, but also, you want to rehearse before you're going to explain what parts are you going to talk more, which other parts you may end up not talking too much, but rather the game teaches you. So you could play a sample round first. You could have in your mini whiteboard some key diagram, etc. So practice makes perfect because you could lose a lot of time just getting over the rules and having students actually understand the game, and you don't want to spend much there. So it's kind of a balance between, okay, let's just jump into the game, but also bear in mind these details. So kind of like a back and forth. And then in part one, there's a challenge, Mari and Noah. So you may skip it if you want to. There's no time, but you may have advanced students that may work on that problem just by themselves. Let's talk a little bit about the goals. And this is a meeting that's similar to separation, the previous meeting about the shapes. So it's also about systems, game theory. And yeah, the big topic is the individual decisions versus the collective consequences. So these games are fun and very interesting because they're dual. They're like a two-way games. First, you can think of them as just competition and you just want to benefit, but over the rounds there's also a communal part to it, so you're also cooperating, so you're also playing together at the same time. So the goals in mathematical is system thinking, a lot about thinking about modeling systems. So we want to represent the outcomes of a game using tables, flow diagrams, and explain outcomes orally and in written language. We also want to state game patterns, laws, or generalities of the form. If we make certain change to the game, then this thing happens. And also justifying formally. We also want to use visuals, such as, in particular, we'll be big in area diagrams and trees to find the odds of certain outcomes in games. So some basic probability here. and also explain how changes to the game can affect the possible strategies using probabilities in the explanations. In terms of enrichment, and this meeting is all about trust and having a very broad discussion about trust and how mathematics interacts with trust, we have these 4 goals: sustain a mindset of collective benefit over individual benefits, appreciate other people's views and disagreements, forgive past experiences in which someone has benefited at our expense, and try to understand the big picture. Again, systemic thinking in the sense of forgiveness, right? I mean, I may have some bad experiences with some individuals, but it's about reframing, okay, what happened? Maybe what were the real intention of that individual? What led to that happening, and having a more, a broader picture. And finally, disrupt. So disrupt the current flow of a decision system. We're part of a game, and sometimes we just feel overwhelmed. So we want to disrupt that and come up with rule changes that allow us for more collaboration and looking for common benefits. So you in the Pear Deck, you'll also have a chance to create your own goal, your own enrichment goal. And so this will be great and will make you reflect about the meaning beyond just abstract mathematical thinking. So write your own enrichment goal. So let's take a quick look now at the 2 games. So the Barrio game, it has 3 parts: introducing the game, playing the game and reflecting, and then going deeper, right? So more problems and variation. So this is the game. Let's go to the manual, the student workbook. So we're all neighbors, but a thief comes to steal all our money. So here's the deal. The expectation is that everybody plays 1 coin, and then, the thief will be happy if at least one of all players put that coin. And then the thief takes all the coins that were offered, so to speak, and leaves. But if no one pays, the thief gets really angry, steals all the money, and the game ends. And that's the worst case scenario. Everybody, will lose the game. So it's an individual game, but also we all kind of play together just not to lose. You start with 10 coins, and it's like a secret decision each round. So, of course, the rules, again, we were talking about this right before. The rules shape decisions. If the rules change, there's incentives or other things, the players will also probably change behavior. So that's kind of the theme for systemic thinking. So if I'm playing with a lot of players, and I kind of expect that at least 1, maybe 2 will, put 1 coin, I may be tempted to kind of cheat and, just put 0 coins, right? Just benefit myself because I won't lose any money. The problem is, of course, if everybody's thinking like me, then we're all gonna lose. So it's like a psychological game. At the end, the players will with most money win. So that's the game. After playing the game, there's gonna be these questions that will lead to thinking about probability. And the 2 key diagrams here that we'll be using, it's an area diagram, which is a bidimensional diagram. This is only for 2 players, so it's a simpler version of the game. Of course, maybe you had 6, 7 students, but now you want to go kind of simpler and just reflect in a 2-player game what would happen. So these outcomes would be everybody's losing or people survive. And of course, I'll read you guys can read the manual in detail and make sense of this. We also have the tree diagram that it's a different way to model the outcomes of the game. And here's Anna, 2 choices. And for each choice of Anna, Ben has also 2 choices. And you have these outcomes. Here we are assuming that the players are playing with a 50% probability. And so you can see, for example, here in Anna's moves, that 2 are zeros, putting 0 coins, and 2 are ones, putting 1 coin. So it's kind of a balance or a mix. Students may wonder what effect does it have if you change the probability? And that's gonna be the challenge, the Maria Noah challenge. They now play with 20% or an 80% probability, and you just analyze what are the expected outcomes of the game. So that's part one. And then part two, similar game, different theme. So we just take it more globally, so to speak. So what will happen here is, let's go to the teaching manual as well. Same start. So now we're countries and we have made a climate change deal. Each year, each country will invest 1 billion in curbing emissions. So each year will be each round, and we'll just have coins to represent billions. So this game is now more secret. Nobody can check for sure if we collaborated or not. So we'll have a bag that players can simulate putting a coin or really put a coin, but there's no accountability. So in other words, if in one round I didn't put any coin, nobody will know. Nobody will know that I didn't put. So I can cheat or deceive the system without any accountability, which of course it happens in real life, and it's more tempting than for countries to, don't pay any money. So here's the deal, kind of similar to the thief. If there's a year or a round in which more than 60% of countries cheated, in the sense that they didn't put any money, you'll have a very serious disaster and players will just lose. So that's the version of the game. And then after playing the game, we'll have this question that presents this tree. So remember that in the first part, we were using area diagrams and trees. Here we just look at a tree because we're actually simulating a game with more than 2 players. So trees are good for that when there's many levels or many, players playing. And kids will make sense of this tree, the outcomes, and work a little bit with probability. So I'll let you guys read this in the teaching manual. Also read the solutions. And there's some fun computations with fractions of denominator 16, which account for good computation strategies. Let's go back to the first part, and I just want to mention that the very first activity in part one, it's a big discussion about fairness, trust, and helping others. So let me show you in the student workbook what we have for that. So let's go here. So this is called Who Benefits, and you have all these questions. You don't have to ask them all. You can, of course, include your own, just knowing your students. So here's a sample. Is it more important to help others or just to help yourself? Do you remember a time when others helped you and you were surprised? Kind of like a positive experience. Can trust be gained back? So these are very general questions. Your job is to kind of bring them down to earth and actually, have students and your fellow mentors come up with or share experiences, real experiences of what happened. So we start from our experiences. Then we're gonna play the game, and hopefully by playing the game, we continue discussing this. Now we're with the math, right? With the systems, with the concrete systems. And then we close and go back to our discussion, in particular, which things were visible during the game from the things we discussed. Did some of your views about trust change positively or negatively? How they change? And hopefully they get more systemic thinking, that you're not playing alone and that you're somehow reacting to some rules of the game, but everybody's doing the same. So, you get some empathy there and more a global view of the situation. For the teaching tips, let's just look at the teaching tips for part 1 to get a general sense of how, which things may be important. So let's go there. And so we have 4 tips. The first is to carry on this discussion that we just saw in the introduction to all the games. Don't forget about that. You could take notes, right? Just to remember key things that people said. Incorporate it in your games. So just bring all what your students are putting in the table. Don't let them just just be forgotten. So try to use them during the whole meeting. You guys are a team of commenters, so in that sense, it's much easier to remember these things. The second is bring your personal touch to the games. And of course, we know the framework component 2.1, make it come alive. So the same thing about cool ideas to introduce the game. And when bringing ideas to the teaching, you will also bring your passion to the meeting and students will pick that up. So it's also a very good motivational tool. Tip number 3, use trees and examples to complement the area diagrams. So you can start with the trees, but also, with the area diagrams, but also go and represent trees. Also examples. So these kind of statements should be used a lot during the meeting by you guys and also by students. If Ben plays 100 rounds, we expect him to put 0 coins in 50 of those rounds and 1 coin in the other 50. And you can change the 100 maybe with 10 or with another number. And of course, this will also change. So it's a very, very good way to understand probability without using any equations, formulas, or things like that, just these examples. And finally, don't be afraid to shorten or simplify the games as you see fit. Make choices to make the game last shorter or just be simpler if you feel that it's getting too long or so. As long as you're achieving the goals, it's fine. So you're guided by the goals, both the mathematical goals and the enrichment goals. And you can get a sense during the meeting, during the activities on how far you're getting in these goals. And if you're good enough, you can simplify the game or move to another part. So that's the game. That's the meeting. Let me just say one last thing about this, which is not minor thing. We are actually raising awareness about climate change in the second game, part 2. And not all students may be aware of climate change, global warming. There'll be a lot of, varying degrees where some students may not know almost anything or very shallow, or other students may be pretty invested. So you have these 3 links. There's plenty more, but at least you can start with these 3 links and also explore climate change and global warming yourself. There's actually a conference going on, which is called COP27, right? And we can, you can actually, let me show you quickly the link. You can raise awareness because it's actually happening right now in these weeks. Oh, sorry, let me go to the climate game. So here in the introduction, so this meeting that is going on right now, COP27, which is happening in Egypt. So, you talk about food security and investing in the future of energy, water security. So make it short, but you can quickly say something about it, and maybe students will browse this website. You can share it and just be more aware of climate change. So it's not a minor thing in our meeting. Okay, you guys, I hope really enjoyed this meeting and have a lot of fun. So see you next time.